Hi everyone. I wanted to take a minute to give you a little video that might help you with the very last part of the lab analysis, the part where you're supposed to analyze the velocity graph for the third case where the cart travels up the hill, pauses briefly, and then comes back down the hill. Now you got a velocity graph that looked somewhat similar to this. It had probably a little part at the beginning where the line went up, a little part in the middle where it went down, and then where you might have had this very last end part over here where it came back up to the middle again. Okay. So this problem asks that this question, the very last question, asked you to compare the sign of the acceleration with the sign of the velocity and to decide how those related when the object was either speeding up or slowing down. So I thought maybe it would make sense just to look at this graph and decode what it's saying first. Remember, this is a graph of velocity versus time. So velocity is on the y-axis and time is on the x-axis. And I want to just take a minute and say, what is this graph telling us? Because there's a ton of information embedded in it. So first, let's look at this beginning part, which I'll highlight in blue. And there's a few things to notice on a velocity graph. First, the sign of the velocity. So let's look at all the points in that blue section. Every point in that blue section is positive. What that means on a velocity graph is that for a positive graph, you're moving forwards, or in this case, that would have been uphill. Now, the value of those points are also increasing. And remember, velocity contains two bits of information. It contains direction and it contains value. The absolute value of the velocity graph, so whether it's positive or negative doesn't matter, just the absolute value, how the actual numerical part of the velocity graph tells you your speed, how fast you're going. So whether you're going positive 50 miles an hour or negative 50 miles an hour, your speed is still 50 miles an hour, it's just the direction that's different. So in this case, in this first part of the graph is positive, so you know that you're going uphill, and the values are increasing, so you also know that you're speeding up. I'm just going to say SU for speeding up. So you're going uphill and you're speeding up. Well, when was that happening? When were you actually going uphill and getting faster? The only time that happened was when the cart was being pushed by your hand. So this little segment over here, which I'll call segment A, is where the cart was pushed by you. The cart was being pushed. And it was getting faster. Okay. Now let's analyze. Each segment gets a little more complicated to analyze. Let's now analyze the second segment of the graph. The second segment of the graph is this little part here. Let's talk about what's happening there. First, let's look at the sign, then let's look at the absolute value. So the sign of these points is still positive. All the dots are above the axis. So that tells us the cart is still moving forwards or uphill, but the absolute value of those dots is decreasing. They're coming back to zero. If the absolute value of the velocity is decreasing, it means your speed is decreasing. It means you're slowing down. So even though you're moving uphill during this green segment, you're also slowing down, SD for slowing down. Think about when that was happening. In segment B, after the cart left your hand, after you pushed it, while it was freely traveling uphill, it slowed down as it traveled upwards because the force of gravity was pulling back on it and your hand wasn't there to overcome that force. So in segment B, it's where it's traveling freely uphill, getting slower. Okay, so that's good. That tells us now we've analyzed the whole first portion of that graph. Now let's take a look at the third segment of that graph. Actually, before we do that, let's take a quick look right at this spot here. Right at that spot, our velocity is 0. Now we know we've traveled uphill, and our velocity is briefly 0. So this is the moment when it's at the top of the trajectory. It briefly stops for a moment before it changes direction and starts to come back down. All right, so now let's analyze the third segment, which I'll do in red over here. So there's the third segment. Notice all the dots over here are now negative. So that tells us the direction, the negative direction, it's coming back downhill. So here it's moving downhill. But now notice the absolute value of the velocity in this case is increasing. The dots are getting further from the axis. They're getting more and more, they're becoming more and more from an absolute value perspective. Your speed is increasing even though the line is moving down. It's getting further from the axis, so the numerical value of these are getting more as you go down the hill. So even though you're going downhill over here, and you're speeding up. And that's a little hard to say because intuitively you want to say maybe that you're slowing down because the line is going down, but you have to remember the absolute value of the speed is increasing. So here you're going downhill and you're speeding up. Okay, so let's think. When you're going downhill, you're speeding up. That's just when the cart turns around and it starts to hurl towards the bottom of the track again, and as it falls down, gravity keeps pulling on it, and now gravity is helping it, and instead of gravity working against its motion, gravity is working with its motion, and it's making it speed up as it goes down the hill. So that all makes intuitive sense. Now let's look at this very last part over here, which you might not have a lot of this on your graph depending on when you stopped timing, but if you have this little part, it's worth analyzing. Again, we can do the same thing. The points are all still negative. So we're still moving downhill. The cart is still coming downhill. However, the absolute value of those points is decreasing. Well, if the absolute value of the velocity is decreasing, it means the speed is decreasing. So here I'm slowing down again. Well, when was I traveling downhill but getting slower? And it's hard to picture, but depending on how the cart stopped, whether it hit your hand and you quickly brought it to a stop, or it hit the end of the track and the little rubber stopper compressed and brought it to a stop, this is where the cart, right at this moment, the cart hit whatever stopped it. But things don't stop immediately. They don't immediately just drop to 0 the way it might look. They actually decrease to 0. And how quickly that line hits 0 is just going to be how quickly it stops. But this area here is really the cart still technically moving downwards because it still goes over a small distance, whether your hand stops it or the rubber stopper compresses it, moves over a tiny distance, and it slows down. And so there's a point here, a range here, where the cart is moving downhill and it's slowing down. And so that's a little bit tricky, but that's why the absolute value of the velocity is decreasing as this black line moves back to the axis. So this is where, let me actually recap this over here. Part C was traveling freely downhill, getting faster. And then the last part, part D, was traveling downhill, being stopped, getting slower. Okay. So now let's very quickly compare what's going on with the velocity to the sign of the acceleration. I'm going to do the acceleration in purple. Remember that acceleration is change in velocity over change in time, which, when you think about it, is just the slope of the velocity graph, because it's the delta rise over run, and the rise is the change in velocity, and the run is the change in time. Well, here, The sign of the acceleration, if we look at the slope, is positive. Notice the velocity and the acceleration are both positive. And that's where it's speeding up. In this second part, notice how the slope has changed. So now the acceleration is negative while the velocity is still positive. They're working against each other. And notice that's where the object is slowing down. Now let's come back to this red part again. Well, here the sign of my acceleration, the slope, is still negative, but my velocity is also negative. In a way, they're pointing in the same direction. They're working together again. Notice how I'm speeding up at that point. And then in this last segment, notice how my acceleration is positive again. So my slope is positive, my acceleration is positive, but my velocity is still negative. So they're working against one another and they're slowing down. I hope that helps you think a little bit about how to analyze the velocity graph in the part 3, where it traveled up and down the hill, and helps you a little bit also filling in that table. We'll talk more about this next week. Have a great weekend.